So I'm honored to welcome to the stage Chris Reeves. Come on.
Thank you.
Are you Superman?
I wish I was,
Okay.
but unfortunately not.
No. But have you ever, because he broke his back on a horse, didn't he?
He did, yes.
That's
And people
tragic.
actually were concerned about it when I went into school, at primary school, the next day, and it was all on the news. People were like, "We thought you broke your back. We thought you were in a horse ride accident."
Oh,
It
they
was
thought
really
it was you?
weird. Yeah, they thought it was me.
Oh, no. And you were like, no, I'm not the famous American actor.
And I was about 10,
Yeah,
so
I'm
it was
a
a
kid.
bit.
Yeah. Oh. Kids, what kind of school did you go to? Very interesting one.
Yeah,
Oh,
very
sounds
strange.
good.
Yeah.
But you have a different middle name.
Yeah, we have
So-
different middle names,
Yeah,
so
that's
that's it.
That's how you can tell you apart. Yeah, plus he is dead.
That true. I
That
do
too.
appear to be alive.
Yeah. Sorry about that. If anyone, sorry, is that a spoiler alert? What's that reaction? He's what? I'm sorry. I know it's sad. He fell off a horse. Please welcome Chris Reeves.
Thanks, Matt, for that very strange introduction. My name's Chris. I am a platform engineer at Banked. I've been writing Go for about 6 years, and these are a couple of companies that I've worked at. And the interesting thing about these companies is not least because I worked with really amazing people at each and every single one of these companies, and I wouldn't be making this talk if it wasn't for every single person I met along the way there. But also, every single one of these companies did instrumentation remarkably differently to one another. And it was a really interesting learning experience moving from application development and moving slowly into more DevOps and the platform areas, which I brought with me to Banked, which is where I currently work. So at Banked, we have a very ambitious goal, which is to basically build a new modern payments platform. And you can see our checkout here. The reasons why we're doing this is because it's more cost effective for businesses and merchants. It's more secure for users. You can see from our checkout flow that you're not entering credit card numbers. You're basically just logging in through your bank and you're making a payment transfer like you would normally. And we're basically building this on the open banking specifications. This all happened around about in 2015 when the EU basically put out a directive to say all banks should basically expose a single API that everybody can talk to and all of that. And in 2016, the UK said that all the 9 biggest banks in the UK should implement this. And by now, there's around about 200 companies working in this space. You've already heard from a couple of them at this conference. TalkPay is one of them. So it's a really exciting space to be in because there's lots of opportunities here. So for Banked, it became really important that we had really good instrumentation because we're talking to lots of different banks. We're making payments, and that kind of stuff is really important to get right and to know what's happening within our system. So obviously, you've all probably seen something very similar to this at many talks at various Gopher conferences or Kubernetes conferences, where you've got a distributed system like this. You've got several microservices all talking to each other or any number of different services. And this is the general happy path, right? This is everything works, it's great. But what happens when something breaks downstream? How do we know about it? How do we debug it? And how do we prevent it from happening again without the customer knowing? So people tend to talk about 3 pillars of instrumentation, but I have a weird, perhaps creepy, different spin on it. I like to think about our applications that we're building as houses. They're constantly changing. We're always removing walls. The foundations are changing. We're always redecorating the interior. And our users are the people who are living in that house. But without good observability, it's a house without windows. So we want to add visibility to that. We want to add observability, basically. We want to be able to see in, because we want to see what the users are actually doing inside that house. Imagine that the TV's not working, or it's only ever switches to one channel, or the microwave's broken. You don't want to have our users coming and complaining to us because that stuff isn't working. We should already know that. So let's start adding some windows to our house. One of the most important ones we should add is tracing. And this is basically following people around the house, which is why it's a bit of a creepy metaphor. But basically, a trace is allowing us to basically trace an entire user request throughout our platform. So a person gets up, goes to bed, uses the kitchen, makes some coffee, I don't know. And each individual trace can have multiple spans part of that trace. And that's when you can start to not only just do service-to-service calls, but you can also start to see in that little code snippet there, which is just some random bit of code, that we can basically have a span that goes through the entirety of our code path. We can get some side effects. We can see some side effects from our services. So let's say you're running an asynchronous system. At Banked, we have a couple of asynchronous services, and a request comes in from a user. We're going to want to know, after that request is finished, what are the side effects, like what happens to the evented stuff that happens later on. So it's not just that end-to-end flow either. We also want to discover performance bottlenecks as well. This was something that happened at another company that I worked at when we added some tracing in. And we actually found like a service that was actually spinning for like 30 seconds. And we were able to like use tracing to figure out why it was slow. So that improved stuff for us. And this is probably quite hard to see, but this is not actually a complete service-to-service node graph, but this is actually just a couple of services with tracing down into all of our different code paths. I'm quite glad you can't see some of that, to be honest, but they're all just mostly HTTP calls and just going into database layers and that kind of stuff. But they're all timed, and we can see where everything's flowing through. And if there was an error on any one of these, they'd be highlighted in red, so we'd be able to go straight down into what's wrong with them. So what about another window? So logging is another traditional observability thing that we can add into our application. Everybody should be adding logs. If you haven't got logs in your application, it'd be a bit strange. And you all know what a log looks like, but there are some general things that you should probably be thinking about doing. Try and make sure that they're structured. It doesn't matter how well you structure, like you can structure them as you see fit. We personally use JSON. It's easy to parse, easy for us to look at. There are a couple of nice logging libraries up there. I personally prefer Zerolog, but there's also Zap, obviously. And logs should try and have enough context on the service, on the log line, to be able for you to debug any particular issues that you have. If it's a log line that says nothing, there's no point in it. You could also consider putting stack traces on, potentially propagating your logger through your context. So some of the stuff we do is that we add attributes onto our logger and pass the logger down onto our context, so it flows through our application. So when an error does happen, potentially down in the database layer, something fairly quite deep, the log line's already got all the stuff on it for us to be able to helpfully debug it because of where it's come from. But the most important thing you should probably put on your log lines are trace and span IDs. So we just went through traces, and you can see here there's a trace ID and a span ID on here. This allows us to link our log lines back to our traces. So when a log picks up an error, or when a trace has an error, we can always get from our traces to our log lines, or our log lines back to our traces. So now we're going to add another window to our house, and it's now going to be a nice, bright, airy house for our users to live in, and that's metrics. So metrics give us a different window into our service. It's more about performance. It's more about how it's operating. Here is just something that we recently added in, which is about our latency and how well our system is working. So you can have counters, gauges, you can have things like error counts. But the other things that these things allow us to do isn't just have nice fancy graphs like this, but we can have alerting that can come off this. So let's say we know that something happens at 2 o'clock every morning, and we can build alerts around that. Business metrics might be something you could put in there. We haven't yet, but it could be something that you want to do. But putting metrics in like this means that you don't have to build metrics from your logs, which can make life a lot easier for you. All of these things are all related to one another. I don't think you can have good observability if you don't have all of these three things, because you can always relate metrics to your traces or your logs to your metrics, All of these things give you a full picture of what's happening in your service. Without one of them, you're only getting a partial view of what's happening. Together, all of these things kind of get called application performance monitoring management. That's the general acronym that gets passed around a little bit. Observability, traceability, that kind of stuff as well. So where does Open Telemetry fit in? So in the beginning, you had to pick a provider. You had to go with somebody like Datadog, or go with Amazon or GCP's built-in metrics and tracing systems. And you would then sprinkle that code all throughout your platform, throughout all of your services. And that basically results in you having vendor lock-in. Imagine that you start scaling up and you're adding hundreds and hundreds, well, hopefully not hundreds, but tens and tens of new services as your product grows. Can you imagine then having to go back through all of those services and then change your tracing provider, your metrics provider? That would be a lot of technical overhead, and it might even become impossible to do. So a couple of things came about to try and solve this problem. The most important two are Open Tracing and Open Census, which were two projects that started up to try and solve this problem. Open Tracing specifically on tracing. Open Census tried to do tracing plus metrics as well, had lots of SDKs. Open Metrics is another one which I think is also still going. As far as I know, it only supports Go at the moment. The difference with that and Open Census was that there was multiple SDKs across different languages. And then these two, Open Tracing and Open Census, basically merged together in 2019 to form Open Telemetry. And they're all members of CNCF, obviously. So the difference that happened was that they became specification driven. So the idea was that they would basically go back to the drawing board and think about what is tracing, what do we need, what is metrics, what do we need, what is it going to look like, what's the implementation detail going to look like, and figure out the specification before we write some code. So the thing about the specifications is that they're in flux, except for the tracing one. So the tracing one is the most important one that they've worked on. It's currently stable and at feature freeze for the API and for the SDK. So the API specification basically says, this is how the tracing API should basically work. There should be a trace provider, that should return a tracer, and a tracer is responsible for creating spans. And a span is a thing that's an operation that we want to trace. SDK is basically the SDK specification, which is stable, basically says, for that API, this is what the SDK should look like. This is what the implementation detail should look like. So tracers create trace providers, and they should have shutdown and flush methods. Like, these specifications are long, and you could read them. I've not gone into any of the depth here. Like, this is just very superficial stuff. And it's the same for metrics, except metrics is at a much more experimental stage. The API spec is currently at feature freeze, so the API spec shouldn't be changing, but the SDK stuff, that is the stuff that's currently changing at the moment. So take everything that's on here with a little pinch of salt, and this does have a side effect on the Go SDKs and all the SDKs for all of the languages that Open Telemetry supports, because obviously things are changing from a specification point of view. So logs are slightly different. Obviously, most languages have had loggers since programming languages have been around. How can Open Telemetry integrate with that? How can it be successful in that space? And it's quite difficult otherwise, because they'd have to implement logging solutions for every language and every perhaps third-party provider. Like, obviously, Go has ZeroLog and Zap, and are Open Telemetry really going to do a pull request into that and sort that out, or even write their own logging library? Probably not. So there's probably a little bit of work that we have to do ourselves to get logging integration in. But there is another thing called the Open Telemetry Collector, which we'll touch on a little bit later. So let's talk about the Go SDKs. There's two libraries, or two repositories, that you only need to care about. That's the Open Telemetry Go one at the top, and then the Open Telemetry Go contrib one. So the first one is the core implementation detail for Open Telemetry, it has all of the basics that you need to get going. It will have your most common stuff, so Prometheus support is in there, Jaeger support is in there, all of that common stuff that most people are probably going to use. The contrib library, on the other hand, has all of the extra third-party bits and pieces that are going to probably be quite specific. So Datadog is in here. They have an exporter for their system, different kinds of propagators, instrumentation for the default net HTTP package, which we'll actually go through in a code demo, and other things like Shopify's Kafka library. So they extensively use submodules, and when I show you the Go mod file, it might make a little bit more sense. But it probably seems a bit weird that the trace SDK is stable at 1.0, and the metric SDK is not at less than 1.0. It's actually at 0.24 at the moment, I think, despite them all being in the same repository and all tagged at those versions. So let's get on to some code demos and hope that this actually works. Let's move that up there. Let's see. How's the visibility on that? Can you guys see that okay? Hope so. Make it a little bit bigger. Okay, so the first demo we'll walk through is the most simplest way that we can get tracing into an application. This is not obviously going to be the best Go code ever written. It's just an illustration of like what you might want to do to get a basic tracing out. And the only thing we're going to do here is we're basically going to print traces out to the terminal. They're not going to go anywhere or be consumed by anything. So we've got an init method here. And this is first setting up our exporter, which is on these lines right here. And this basically is going to be where our traces get exported to. It's standard out with a pretty print, so it would basically be JSON formatted. And then we're defining a resource, and this is something that you can do in your services. And it basically defines the common resource attributes or labels that you want to propagate across all of your metrics, your traces, for example. So we've got a service name in here, we've got the service version, we've got an environment, so production, staging, whatever, and any other custom bits and pieces you want to send along. Like I've got a random attribute in there called ID with 1, 2, 3, 4 as its value, and it's just key value pairs. And then we create a provider. So this is the thing that actually is going to allow us to create our traces. So we basically create a new trace provider, and we say that we want to batch these. In production, it's useful to batch these up. And then we pass in our resource. So the provider has that to pass along to our traces. And then we set our tracer, and our tracer is the thing that allows us to create spans. And all we have to do here is basically give it a name. Usually, you would basically give it the module name, the package name that you're tracing. Here I've given it our module for this particular demo. All of these are getting saved as set as global variables at the top, so we have access to them later. And then in this main file, it's really simple. We've got a background context, and then we've got a defer function, which is going to shut down our provider, and our shutdown for the provider will ensure that any traces that haven't been sent when our application shuts down gets flushed out and sent. And then we create our first span, which is here, tracer.start. And we give it a context. We're going to get a context back out because the context is going to have the span that we just created on it. And we're also going to get the current span that we're operating on. And then we call a defer span end. So this will get called when the function exits. And then we're going to pass that context into this random foo function. And that's going to take our context, and then we can start another span down here. And that is basically going to allow us to create a child span from the parent span that was created before it. And then I'm just simulating some work with a time.sleep. So we pray to the demo gods, and we hope that this runs. All right, so that's not going to look great, but hopefully you can see it. So the first span we got out from that was our foo function. and that has a trace ID on it, and it has a span ID. And you can see that it's got a parent on it as well, which has got the same trace ID, but a different span ID. And then further down, we can see that our resource has all of the information that we provided in that resource method, in that resource definition. And then the next span on here will be the parent one. So they all get sent out in order. But its parent is basically set to 000 because it has no parent. So this one would get ignored by anything processing it. And again, but it still has all the resource information. So that's the basics of just adding some basic tracing and being able to see what you would be tracing. But that's not very useful and not very interesting. So let's switch over to the second demo where I've got pretty much exactly the same code, except up the top here, I'm switching out the exporter for Jaeger. So if you don't know what Jaeger is a trace provider, processor. It gives you a nice UI to your traces. So all we have to do is just do go run. Okay, so that's given me a trace ID. So it just printed that out for me, so I can just copy that. And then over here in our Jaeger UI, this is just running in a Docker compose. It's just running locally. Nothing special here. I just copied it from their examples. So now in here, we can see that there's a demo2 service in here, but I can just basically paste that trace ID straight in here. And that is the UI representation of our trace. So if we expand that a little bit more, we can see that all of our information that was sent along with that resource is in here. That ID is in here, the environment, the service version, the service name, the library name, all that kind of stuff is all in here. And then it goes down to the foo function, and it took roughly about a second, because that's the timeline along the top. So you can see that it took a second, because I've got a time.sleep for a second. OK, so that's Jaeger. But again, so that's pretty straightforward and simple. What about, just undo any changes I made there. So what about two HTTP servers that we want to talk to each other? So this is where things get more interesting, and we start to want to use the Go contrib library. And actually, before I do that, I promised you a view of the Go mod file, so I'll show you the Go mod file. And this is what it kind of looks like. So you can see in this Go mod file, some of the Open Telemetry stuff here is tagged at 1.0, and other stuff is tagged at 0.24. And everything in here, despite it all being in the same repository on GitHub, all gets vended separately. Their reason for doing that, obviously, is that if Open Telemetry had Amazon or GCP and all that kind of stuff, you don't want to bring down Open Telemetry and basically the world. You just want to bring down what you're using, so that's why it's all sub-moduled. So I only bring down what I need for this code to compile. So I'll head back to demo 3. All right. So this is where things get a little bit more interesting. So at the top here, I'm creating a new propagator. So a propagator is how we're going to propagate our traces between our two services. There's multiple ways you can do that. We use B3 at Banked. So if you're not familiar, that's basically just sending HTTP headers between two services. It's x-b3. You can send that as one big string, or you can send multiple different headers for multiple different things. You say x-b3-trace ID, x-b3-span ID, that kind of stuff. So that's the propagator we're going to use. We're still going to send stuff to Jaeger, so this bit hasn't changed. Our resource hasn't changed other than the service name. Our provider hasn't changed, and other than the tracer name, it hasn't changed. We've still got our provider shutdown, but here is where we're basically going to start a HTTP server. So, I mean, I'm showing you service B here, but service A is basically exactly the same as this. So these guys have a handler on it, and this handler gets wrapped in the OTel HTTP handler. And what that does is that will automatically extract spans and traces that have come across those HTTP headers and update the request context to have a span on it. And it will also do automatic instrumentation for metrics. So it will automatically count the bytes in and out, the request count, that kind of stuff. And it'll have a gauge for other bits and pieces as well. It's all open source, and you can go and view what it does. Or you can fork it and add more metrics if you need to. So we basically start a HTTP server, just doing this in a Go routine. Got some OS signal listings here. This is the handler function that we're wrapping in that Open Telemetry middleware. It's basically just going to print out. It's going to create a new span from our request context. It's going to call that foo function. That's going to sit and spin for a second. But we are also going to print out our trace ID as well, so we can have a view on it. The other thing that service A does that's a little bit differently, because service A is going to talk to service B. If I go to the right window, is down here. We are going to create a HTTP client. So obviously, if we're doing HTTP requests going out, we also need to propagate the trace information on the outgoing request headers. So they obviously provide you a way to create a transport. Sorry, as I jump around. To create a transport with your propagator on it. You can set this globally as well. You can set this so it's your default. But here we're doing it explicitly. And then this function, this service B function, is just going to create that client and then do a HTTP request to service B. So hopefully these two should already be running. So I'm just going to do a get request to localhost on 3000. All right. So we can just add this trace ID. Put that in here instead. And we get two different traces. So now we can see that service A has called service B. And we have a complete trace end-to-end with all of the same tags and information all on the traces. And it allows us to see what's happening. So next, I did mention logs earlier. This demo is like really simple. It's basically a standard HTTP server that we've just basically had, but we're going to use zero-log to basically inject the trace ID and span IDs onto the log lines. This is the bit of manual work that you might need to do, depending on how you want to handle your trace IDs on log lines. So I won't go over all this code again, because it's pretty much exactly the same, except down here, I've got this zero-log hook function, which basically takes a span and then checks if the span is recording. So the other thing you can do with spans and traces through your configuration is you can say, in production, you only want to sample 30%, 20% in production, whereas in staging, you might want to do 100%. So this is recording basically checks, is this trace actually a sample trace? And also, if you're creating traces as well, you're sending them manually through HTTP headers, you can force the sampling to be turned on as well. So you can force a trace to be sampled in production if you're debugging something. So here we've got, we basically get the trace ID, we get the span ID out, and we just add attributes onto the zero-log event. If you've not used zero-log before, it might look a bit strange. But basically, all this is going to do is I'm just going to run it. This will be on 5,000. No, it'll be on 4,000. And then the log line up the top is a little bit more pretty printed because it's zero log and it's console output. We can see the span ID and the trace ID out on there. So if you were sending your log lines out to standard out and these would be getting hoovered up by something and then pulled into something like Loki or whatever logging provider you're using, you can then link up your traces with your spans. And then the fifth and final demo will be metrics. So this has been running the whole time whilst I've been doing this talk. So the metrics SDK, as I mentioned, is a little less stable. It probably will change as the specification changes. So every time you pull down a newer version of Open Telemetry, you might have to move some things about. Things will change. That's the kind of trade-off you have to pay at the moment for using that. But at the moment, it's very similar. We've got a thing called a controller, we've got an exporter, and we've got a meter up there. So we basically do mostly the same stuff. We create a resource. We configure a metric controller. Here you can set what kind of histogram boundaries you want. At the moment, I'm just using the defaults. If we're doing histogram stuff, we pass our resource into the controller. We create a Prometheus exporter. And then we basically set our global meter provider. And then we create a meter for it. So this function, again, I've just done this in some wait groups. So because it's serving a HTTP server, so obviously Prometheus is a pull model rather than a push model. So Prometheus needs to be able to scrape the metrics. So the Prometheus exporter, it actually implements the serve HTTP interface, so it can provide those metrics for you. So you can just put the exporter straight on the handler there, or you can put it on a different URL, whichever router you're using in your application. And we start HTTP server. And then I've got this just make metrics function, which is just a for loop, just ticking every 5 seconds or so, and just randomly counting. So we've basically got a counter up here. We could add all kinds of different counters, histograms, gauges, whatever you need to be able to have metrics on. We can just create a counter up here, and we're just incrementing that. Basically here, just getting a random and just adding that on here. So this has been running, but let's see what happens when we actually just hit that server on port 6000. So this is exactly what Prometheus would see. It's great, so you can see that it's got all of the attributes and labels that are on there that we wanted from our resource. And it's also got the value on the count there. So if I now go over into Prometheus, I'll just rerun this query. This is just random, so this isn't very useful at all in terms of like doing anything interesting with, but you can see that the metric is basically coming in, Prometheus is scraping it, and we've basically got a sum for and we're rating it. I'm not the best on Prometheus query language, but this basically gives us a nice little graph for the random counter that we've got going on here. So those are the code demos, but we're not quite finished yet because let's hope that this works. Because we may not have actually really solved a problem, because we still have in our code, we still have each provider written as an exporter in our code for our traces and for our metrics. So still, if we wanted to switch out Datadog for something different or add Amazon to it or Stackdriver, whatever, we've still got to go through our code and redeploy our services. So it hasn't really solved a problem. And that's where the Open Telemetry Collector comes in. So instead of doing it the way I kind of showed you, you would basically have each one of your services would all send their metrics, their traces to the Open Telemetry Collector. And you would deploy this as a piece of infrastructure in your code, in your system. And then the collector is then configured to send your metrics and traces out to wherever you want. It's not just this, though. It can do so much more, which I'll show you on another slide. Obviously, Prometheus is being a pull model rather than push. The collector can expose a metrics endpoint for Prometheus to pull metrics from if you're using Prometheus. So this is just lifted directly out of the Open Telemetry Collector documentation. It can do so much more. It can do processing on your traces and metrics, like it can automatically add labels to stuff. You can filter stuff. You can prevent traces from getting processed. There's all kinds of stuff you can do. The documentation is pretty okay. It's all configured through YAML. So as you can see here, like you can have Open Telemetry Protocol here, which is basically just a gRPC protobuf protocol that they've created. Or you can have Jaeger and Prometheus and that kind of stuff. So if you're operating in Kubernetes like we are, managing the deployment of that might seem a bit difficult. So there's the operator as well. So you can install that into your Kubernetes infrastructure, and then the operator can just manage your collector deployments for you. So you can end up with something that looks a little bit like this. So you have a Kubernetes namespace, and then you have a pod, which has your service in it. And the operator is configured to watch for new pods in your namespace. This will create and inject a new collector sidecar into your service. This means your service is just sending stuff to localhost using the Open Telemetry protocol, and then that sidecar is just sending stuff all out to wherever you want. Again, the collector can also have a /metrics endpoint on it for Prometheus to pull stuff down from. But you can do it another way as well. So let's add some complexity into it. So let's imagine we've got an asynchronous service. Asynchronous services may not be able to have sidecars injected to them. Maybe they're running in Cloud Functions or Lambda or something like that. So you're still going to want to get metrics from them and traces. So instead, you can have a collected deployment, again, all managed using the operator that's sending the metrics and traces up to wherever you want, and you're still running the sidecar for your synchronous services, again, all with Prometheus support. You could slice it a different way. You could continue to have a sidecar that then just sends all your metrics into one main collector deployment. That could be a node deployment, so it's on each of your cluster's nodes, or it can just be a regular deployment that auto-scales. And then that just sends stuff out to Datadog or Cortex or Honeycomb, whatever backend provider you want to use. And actually, I think this is actually the current solution we have. We might be moving to something more like this, where we still have the collector sidecar having a specific endpoint for metrics on there, but traces will just still go through the deployment. So wrapping up, so hopefully I've done a decent job of showing you that Open Telemetry is potentially going to be a really powerful tool for you to instrument your code, to add traces to your code, and for you to get some more observability and insights into what's happening within your system, create alerts, and for you to be able to customize where you send your metrics and traces. You're not vendor locked in anymore. The choice is yours who you want to use. And you just use Open Telemetry as the main SDK implementation. For us, we are hiring, obviously. Everyone else is. All of our job specs are on GitHub, or you can just come and see me. It's a really exciting space to work in for the open banking and payments space at the moment. Banked itself is going through a really exciting time as well. We've got lots of interesting technical challenges to figure out. So if you're interested at all, hit us up. And that's it. Thank you.
Excellent stuff. Do we have any questions for Chris Reeves? Yes, we do. Here we go.
Okay.
Here I go. Just going to go gently. If I make those noises, it sounds like I'm going fast. Sorry, who put their hand up? Ah.
Thanks, that was really interesting. You mentioned propagators
Yes.
for adding, I suppose, metrics to HTTP requests, so you get a better picture overall. Is there anything like that for queues or lambdas or kind of more locked-in stuff?
There might be in the Open Telemetry contrib library. There might be stuff in there for Lambda and Cloud Functions for you to plug into. In the past, I've had to do that myself and write a little wrapper around that. So you might have to do that yourself depending on what you're using and what Open Telemetry has available in the contrib library. Obviously, it's open source, so if you do write something for, I don't know, Cloud Functions, if you're using that, or Lambda, always contribute it back in. They'll be happy to receive pull requests.
Cool, thanks.
Or OpenFAS, of course.
Or OpenFAS.
Any other questions for Chris? Here we go.
Hi, thanks for a great talk. For queues or like streaming, do you keep your same trace ID for the queue, or do you create a new trace ID?
So we would, at the moment, we do have some asynchronous stuff, but the traces aren't actually on the asynchronous stuff at the moment. But at previous companies I've worked at, we have put the trace ID as metadata onto the event that's gone onto the queue. So basically, a user comes in, makes a HTTP request to the front end, does some stuff, we emit an event. That same trace ID that was on that original request is on that event. So you could potentially, depending on how long you keep your traces around, you could eventually have, like, say, 2 weeks later, an event pops up because you want to send out a notification email or something. You could get all the way back to that original request if you wanted to. So that's what we do.
Yeah, good question, that one. Any other questions for Chris while we have him here? Just rotating to see. Oh, I've gotten dizzy. No, that's it, Chris. You're free to fly off. Thank you so much, Chris Reeves.